This is section 4.1, part A, right triangle trigonometry. So our trigonometric functions, remember if our angle is here, the side that's across from the angle is called the opposite side. The side between the angle and your 90 is called the adjacent side, and the side that's across from the 90 is called the hypotenuse. Now we do have 6 trigonometric functions. The sine function, which can be abbreviated sin, the sine of theta is equal to the opposite side over the hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. Cosecant of theta is just the reciprocal of sine, so it's just hypotenuse over opposite. Secant of theta is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it's just adjacent over opposite. So like I said, those are reciprocal functions. It means I can just take the fraction and flip it upside down. So cosecant is just the reciprocal of sine. So cosecant is equal to 1 over sine of theta. Secant of theta is equal to 1 over cosine of theta. And cotangent of theta is equal to 1 over tangent. Now, from their given definitions, we can actually simplify these functions and derive tangent and cotangent using sine and cosine. So tangent is actually equal to sine over cosine, and cotangent is equal to cosine over sine. Now we need to find the exact values of the 6 trigonometric functions. The exact values means we are going to leave these into fraction form. So the first thing we're going to want to do is label our triangle. So if this is our angle, remember the side across from the angle is the opposite. The side between the angle and the 90 is the adjacent, and the side across from the 90 is called the hypotenuse. Now we know that the sine of theta is equal to opposite over hypotenuse. Our opposite side is 8, our hypotenuse is 17. As long as we don't have any radicals in the denominator, we can leave our fraction in this form. If you want to reduce your fraction, if it is reducible, that is acceptable as well. We know that cosine of theta is adjacent over hypotenuse. Our adjacent side is 15, our hypotenuse side is 17. And we know that tangent of theta is opposite over adjacent. Our opposite side is 8, our adjacent side is 15. Now if we do the reciprocal functions, we know that cosecant of theta is the reciprocal of sine, so we know that it's hypotenuse over opposite, or you can just take your sine function and flip it upside down, so it's just 17 over 8. Secant of theta is the reciprocal of cosine, so it's just hypotenuse over adjacent, or you can take the 15 over 17 for cosine and flip it and get 17 over 15 for secant. And cotangent of theta is adjacent over opposite, or it's the reciprocal of tangent, so it is 15 over 8. Now we need to find the exact values of the other 5 trig functions. So right now, if we have a right triangle, because this is right triangle trig, and we know cosine is 2 over 5. Now cosine we know is the adjacent side over the hypotenuse. So if this is my angle, we know our adjacent side is 2. We know our hypotenuse is 5. We need to find the length of that opposite side. Because this is a right triangle, we can use Pythagorean theorem. So we do know that a squared plus b squared is equal to c squared, or our opposite side squared plus 2 squared is equal to 5 squared. Now if we take that 4 to the other side, we're going to get that our opposite side squared is equal to 21, or to get rid of that squared, we'll take the square root of both sides, and we know that the opposite side will be the square root of 21. Now remember, when you do take square roots, it can be a positive or a negative value, but since we're talking about a length cannot be negative, so it is going to be a positive 21. So now if we find the remaining 5 trig functions, remember sine is opposite over hypotenuse, so our opposite side is radical 21, our hypotenuse side is 5. We already know that cosine of theta is 2 over 5, and tangent of theta is opposite over adjacent, or our opposite side is radical 21 over our adjacent side of 2. Now when we go to do those reciprocal functions, again, you can just take sine and flip it upside down. So this is going to be 5 over radical 21. But we cannot leave a radical in the denominator. So to get rid of this, we're going to multiply the top and the bottom by radical 21. This is going to give me 5 radical 21 on top and radical 21 squared on the bottom. Or when you square root, that's going to cancel. So it's just going to give me 5 radical 21 over 21 as the cosecant of theta. To find the secant, remember it's just the reciprocal of cosine, so I can just flip cosine upside down and get 5 over 2. And to get tangent, to get cotangent, we already have tangent. Cotangent is just the reciprocal of tangent. So this is 2 over radical 21. But again, we cannot leave that radical 21 in the denominator, so we can multiply the top and the bottom by radical 21. 2 times radical 21 is 2 times radical 21. Radical 21 times radical 21 would be radical 21 squared, but remember that square is going to cancel the square root, so you will just be left with the 21 on bottom. Now you will often be asked to find trigonometric functions of specific acute angle measures, and so this table is going to give us the 6 trigonometric functions for the 3 most common angles. So any triangle that you have that has if you're looking at an angle and it's 30 degrees, then the sine of the angle, once the fraction is reduced, would always reduce to be 1/2. The cosine of theta will always reduce to be radical 3 over 2. Tangent will be radical 3 over 3. Cosecant would be 2. Secant would be 2 radical 3 over 3. And cotangent would be radical 3. We have the same rules for 45-degree angle and a 60-degree angle. And we will see all of these pop back up once we get to our unit circle. But if this is not one of those common angles, we can use our right triangle trig to solve to find the missing side. So if we know the angle and we know one of the sides and we're looking for the other side, the first thing we have to do is to determine which sides we already know. So if this is our angle, this side is between the angle and the 90, so we do know that it is the adjacent side. And this side is across from the 90, so we know that it's the hypotenuse. Now once you've identified what sides you have, then you need to pick which function to use. So which of our trig functions uses adjacent and hypotenuse? This would be cosine. So we know the cosine of 42 degrees is equal to our adjacent side over our hypotenuse. Now before you go to solve this problem, you do need to make sure your calculator is in degrees. To check this, if you have a graphing calculator, you can hit mode, make sure it is on degrees and not radians. Now to solve this problem, right now we have x divided by 18. The opposite of dividing is multiplying, so we can multiply both sides by 18 to cancel out that denominator to get the x by itself. So we do know that x is equal to 18 times the cosine of 42 degrees. And if you put that into your calculator, you should get that x is approximately 13.4. A competitor in a triathlon is running along the course shown. Determine the length in feet the runner must cover to reach the finish line. So the person is here. They're going to run along this side. This side is across from the 90, so this is the hypotenuse. If this is our angle right here, the angle is across from this side. The angle across from the side is called the opposite side. So the trig function that uses opposite and hypotenuse is sine. So once again, we first have to determine what sides they gave us and then determine which trig function goes with those sides. Now your calculator has sine, cosine, and tangent on it, so the three first trig functions are the ones we're going to go towards, not the reciprocal functions. Now we know that the sine of 63 degrees is equal to your opposite side, which is 200, over your adjacent side. Now we do need to get the x by itself, but right now the x is in the denominator, so we will multiply both sides by x first. So those x's will cancel out of the denominator, and we will be left with x times the sine of 63 degrees is equal to 200. Now, the x is still not by itself, but right now we have x times the sine of 63, so we can divide both sides by the sine of 63 degrees. So this will leave us with x is equal to 200 divided by the sine of 63. And if you put that into your calculator, you're going to get approximately 224.5 feet. So far in these problems, we have known the angle and we've been looking for a missing side. But it is possible that we can know sides and have to find the missing angle. To do this, we need to use the inverse trigonometric functions. So we can use the inverse sine, which looks like the sine -1 of x, inverse cosine, or inverse tangent. So if I know that the sine of theta is equal to 3/4. To get the angle by itself, to take the sine to the other side, you are going to have to do the inverse. And if we do the inverse sine of 3/4, we would get our angle is approximately 49 degrees. So anytime you're looking for an angle, you will always use the inverse. So we're going to use a trigonometric function to find the measure of theta round to the nearest degree. So again, first we have to identify which angle we're looking for and then what sides we are given. So this side is across from the angle, so we know it is the opposite. Over here, this side is between the angle and the 90, so we know it is the adjacent. Now our trig function that uses opposite and adjacent is tangent. So we know that the tangent of theta is equal to our opposite side over our adjacent side. To get the theta by itself, to move just the tangent, that's when you do the inverse. And if we do the tangent inverse of 26 divided by 11 and we round it to the nearest degree, you should get that theta is approximately 67 degrees.